Welcome to Monkey Physics IIT JEE NEET Foundations.
Yeah, now let's talk about acceleration. It is represented with A. Of course, this is also vector. Now, how do you define this? Acceleration is equivalent to we take change in velocity upon the duration of time in which this change occurs, and it is given as delta u. Delta v upon delta t. Change in velocity upon the time. Now, this can be written as final velocity minus initial velocity upon time, and this is also written as v minus u upon t. Final velocity f, of course, initial velocity. Later on, we see that it is a function of time. Now, this is also given as dv by dt, like to say the acceleration at a particular instant of time. Now, what is the unit? Unit of this acceleration is meter per second. And the dimension, how do you write L by, of course, meter per second per second. Look at here, acceleration, na? How much velocity is changing per every second. So the velocity change, it is in meters per second, and it is given as L t square. This is taken as L t power minus 2. Now, let us understand this. Suppose acceleration due to gravity is 9.8 meters per second square. That we know, right? Now, this can be written as 9.8 meters per second per second. So, look at the definition. There is a change in velocity for every second. Then, how much is the change in velocity for every second? 9.8 meters per second. If I, for the calculation purpose, if I take 10 meters per second, look at this carefully. G is equivalent to, for every second, there is a change in the velocity 10 meters per second. What does it mean? Look at here. The object is falling down. Here it is velocity. U is equivalent to 0 when it is dropped from some height. Now, after 1 second, you can say, for 1 second, what is the change in velocity? So, 10. So, its velocity is 10 meters per second. Then, what is the change? 10. For how much time? 1 second. Now, t equivalent to 2 seconds. There must be change in velocity 10, isn't it? Now, how much is the velocity at that instant? 20 meters per second. Now, what is the change in this second? 10. Now, what about when t equivalent to 3? What is its velocity? 30 meters per second. What is the change? 10 only for 1 second. And look at the acceleration definition, like how much is the change in velocity for every second? Change in velocity for every second. So, that is what we wrote here. 10 meters per second for every second. That is why meters per second upon second. So, meter per second square. So, the dimension L t power minus 2. Now, here, how many cases even this acceleration we can see? Now, this like a motion of object, if you consider, based on acceleration we see. Based on acceleration. So, entire kinematics, from the beginning itself, whatever so we are discussing. So the motion is divided into first case 0 acceleration, second case constant acceleration, and the third case variable acceleration. Now, entire kinematics, whatever the case, the study about the motion of the object you consider, it falls under any one of these categories. Now, 0 acceleration, A equivalent to 0, and constant acceleration when A equivalent to constant, and variable acceleration when A is equivalent to variable. Now, this 0 acceleration case also called constant velocity. Why? Because, how do you define the acceleration? Acceleration is defined as change in velocity, right? Now, when velocity is constant, there is no change in the velocity. So, acceleration is 0. Therefore, in this case, is there anything to study about the motion of the body? Means it's a simpler case, we can say. Velocity we define as displacement upon time, right? And displacement is given as velocity into time, right? And what about velocity? Velocity is given as displacement of, time is given as displacement upon velocity. Of course, vector by vector is not possible. So that is, sorry. Okay. And wherever we want to write the time, it's a S by V we can write. Now, coming back to constant acceleration. Now you define constant acceleration. It's given as change in velocity upon time. Change in velocity upon time. Now, how do you calculate? At is equivalent to V minus U. Bring this, V is equivalent to U plus At. bring u left side and at right side. So this is v is equivalent to u plus at. And this is also called first equation of motion in kinematics. Now based on this we want to derive s is equivalent to ut plus half at square, one more relation, and v square is equivalent to u square plus 2as, one more relation, and Sn is equivalent to u plus a by 2 into 2n minus 1. This is one more relation. And of course, displacement is given as u plus v by 2. So this is what we call average velocity into time. So this is also we give as relations. Now please remember, these all set of equations valid. These are valid only for constant acceleration. Only for constant acceleration. Please remember. Yeah. Now coming back to acceleration when it is variable. Now we can discuss this acceleration as a function of time. How to deal with this? And acceleration is a function of position. How can we deal with this? And acceleration is a function of velocity. How do you talk about this? So these are all the cases we are going to discuss now.